Hey everyone, and welcome back. So in our last explainer, we covered how Go programs store information using variables. But today, we're taking a huge step forward. We're going to teach our programs how to actually think. We're diving deep into how programs make decisions, which is really the secret to building smart, interactive applications. I mean, think about it. The best software out there doesn't just sit there holding data, it actively reacts to it. So how does a program look at the information it has and decide what to do next? That's the core question, and that's exactly what we're going to break down today. So here's the game plan. We're going to cover what conditionals are, get into how if, else, and else-if statements work in Go, and then we'll look at the comparison operators that make the whole thing tick. All right, let's dive right in. So first up, what are conditionals? Well, you can basically think of them as the brain of your program. At their heart, they're just a way for your program to ask questions and make decisions based on the answers. And we're not talking about deep philosophical questions here, right? We're talking about super practical stuff that happens millions of times a second. Things like, is this user actually logged in? Did that credit card payment go through? Hey, is that item even in stock anymore? The answers to these questions completely change what the program does next. The basic logic is actually super simple, but it is incredibly powerful. It all boils down to this. If this one thing is true, then you do this specific action. Otherwise, well, you do something else entirely. This simple if-then-else idea, it's the foundation of pretty much all complex software logic out there. Okay, so theory is great, but let's see what this actually looks like in Go code. We'll kick things off with the most basic form of a conditional you can write, the simple if statement. This is where your program takes its very first step into making a choice. All right, check this out. We have a variable age, and we've set it to 18. Then comes the if statement. It's asking a simple question. Is the value of age greater than or equal to 18? Well, in this case, it is. So the code inside those curly braces runs, and it prints out, you are an adult. Now, what if we had set age to, say, 17? The condition would be false, and the program would just skip right over that block. Nothing would happen at all. Let's break that down piece by piece, because the structure is really simple. You have the if keyword, that's what starts the whole thing. Then you have the condition itself, age greater than or equal to 18. This is the question, and it has to evaluate to either true or false. And finally, you have the curly braces. They create a block of code that only gets to run if that condition is true. Simple as that. Okay, but what happens when the condition is false? In that last example, literally nothing happened. So how do we handle that otherwise part of the logic? Well, for that, we need another keyword, and that keyword is else. See? Now we've added an else block. This gives our program an alternate path, a plan B. We've set age to 16 this time. So the if condition is age greater than or equal to 18. That's false. So Go just completely ignores that first block and jumps right down to the else block, and it prints, you are underage. And just like that, we're handling both possible outcomes. That's perfect for two options, right? A simple yes or no. But let's be real, life is usually a lot more complicated than that. What if you've got multiple different conditions you need to check one after another? Well, for that, we use else if. Okay, so when you have more than two paths, you just chain them together with else if. Think of it like a waterfall. The program starts at the top and checks the first condition. Is the score, 85, greater than or equal to 90? Nope. So it flows down to the next level. Is 85 greater than or equal to 70? Yep, it is. Bingo. So it runs the code in that block, printing good, and this is super important. It stops. Its job is done. As soon as it finds one true condition, it doesn't even look at the rest. All right, to build all these powerful decision-making statements, you need the right tools in your toolbox. The actual building blocks for the rules inside your if statements are Go's comparison and logical operators. So here are the essential comparison operators. You've got your double equals for checking if two things are exactly the same, not equals, and then your classic greater than, less than, and the or equal to versions. You can think of these as the verbs of your conditional sentences. They're what let you ask the actual questions. And here's where it gets even more powerful. We can combine rules. If you use the logical and operator, that's the double ampersand, both conditions have to be true for the whole thing to be true. But with the logical or, the double pipes, only one of them needs to be true. This gives you a ton of control over how you build your logic. Okay, so we've got the fundamentals down pat. Now let's jump into a couple of cool Go-specific features and a really, really common trap that you'll want to watch out for. Okay, now this is a super neat feature that's pretty unique to Go. You can actually declare and initialize a variable right inside the if statement itself. See that temperature equals 30 part? That variable gets created right there on the fly. But here's the best part. It only exists inside that if-else block. As soon as the block is over, poof, the variable is gone. It's a fantastic way to keep your code really clean and tidy. All right, everybody, pay close attention to this one because this is probably the #1 mistake beginners make in a lot of programming languages. A single equals sign is for assignment. It means make this variable equal to this value. A double equals sign is for comparison. It asks, is this variable equal to this value? Now, the awesome thing about Go is that it's a smart language. If you accidentally use a single equals in an if statement, your code just won't compile. It literally saves you from shooting yourself in the foot. But understanding that difference is absolutely critical. So why do we just go through all this? Why does it matter? Because conditionals are literally everywhere. They're the engine behind login systems. They're what validates your credit card payment. They're what checks if an item is in stock on an e-commerce site. Pretty much any smart feature you can imagine is powered by this kind of logic. They are truly the backbone of any reactive modern application. And this quote really sums it up perfectly. Without conditionals, your app couldn't react to anything. It would just be a dumb script running blindly, doing the exact same thing over and over again, completely unaware of the world around it. All right, let's wrap this up with the key takeaways. Conditionals, they're what give your program a brain. You use if, else, and else if to control the flow of your program, to create different paths for it to take. And you build the rules for those paths using comparison operators and logical operators. You now have the tools to write much, much smarter and more reactive programs in Go. And that really brings us to the final thought. You've just unlocked one of the most fundamental powers in all of programming, the ability to make your code think and react. So the only question left is, now that your code can think, what are you going to build first? Thanks so much for watching, and I'll catch you in the next one.